So welcome to this webinar. I'm David Melamed, co-founder and CTO at Jit, and Yarin.
Hello, everyone. Thank you so much for joining the webinar. My name is Yarin. I'm leading all the solutions architecture here at Upwind and part of the founding team and field CTO.
Awesome. So we wanted to share with you today a very interesting topic that's called, like the webinar is called Automating Supply Chain Security with AI Agent and Runtime Intelligence. And it's actually a lot of words to explain something that is very simple. Basically, is that today there are new ways to take care of your supply chain security. A little bit about the agenda. We'll discuss first the risk. Why do you need to care about your supply chain? And then we'll talk about the current challenges with the current state of how usually people are taking care of supply chain attacks. And then we'll propose a new novel way to actually take care about it by combining both both products, like both companies like Jit and Upwind. And we'll show you a quick demo, and then if you have any question, we'd be happy to answer. All right, so let's start. And first of all, let me take you down the journey of the supply chain risk. And how basically, since we added AI to the mix, it's actually a way more challenging risk that everyone should take care of. So if you're thinking about the life cycle of a CVE, basically everything starts the day a CVE is disclosed. So a CVE is a vulnerability that is tied to an open source package, and basically one day it's made public. Okay, and then it's recorded in one of the database, NVD or any other database that stores CVEs. Now, the next day, an attacker actually builds an exploit with AI. And that can happen very quickly, because now with AI, you can generate exploit on any type of vulnerabilities really easily. And so once you generate the exploit code, you're basically can go and test that in an environment. The thing that AI made actually possible is that now he lowered the barrier to generate this exploit, and basically shortened the time to weaponization. So now the attacker can test that in any environment. And there's multiple scripts that can be written to basically try and attack environments out in the wild very easily and at scale. And that's actually what's make it super dangerous. And so finally, there's the CVE is resolved, and companies are actually updating their the packages that has the vulnerability. Now, if you look at this chart and this timeline, there is this red line. It's called like the exploit window. It's basically the time between the first attacks, the first test by the attackers, to the time that the CVE is resolved. As you can imagine, with AI now and the fact that it can go and you can go and scale the attacks, that exploit window is really critical, and you need to shorten that as much as possible. But the thing is, even if it's simple for a single CVE, the really challenge that you will need to take care of is the scale. If you have thousands of CVEs, how can you deal with that? So let's try to see what is the traditional way of dealing with supply chain attacks with SCA. So everyone knows SCA. SCA is like a software composition analysis. There's a lot of scanners out there that help you detect those issues. So usually the different steps are the following. You start by detection, and then you're doing a triage, and then validation, and then remediation. The detection is the first phase. This is the phase where you just scan all your open source packages, and you go and try to find if there's anything that is impacting your environment. So let's start with there. The detection is basically the first phase where you have your scanner, and usually it can generate thousands of CVEs. So that's basically a problem because it can be extremely time consuming to understand which ones are relevant and which ones are not, which are the ones that you want to fix and which are the ones that you can ignore. So once you detect, you have like all these CVEs in your list. The next stage is basically triage. You need to understand which ones are really important for you to fix. So how do you know something is a priority? First of all, you only care about what's really a risk for you. So the first parameter you can take into account is whether or not the finding is related to software that is deployed to a production environment. If it is deployed to a production environment, it's a priority. If not, then you can ignore it safely and then either deal with it later once you will deploy to production or never touch it and leave it like that. The second is it really exploitable? So first of all, you want to understand if, for example, the package and the service that has this finding is internet facing. Because if it's internet facing, then there's a way you can exploit it easily, or at least more easily than if it's not internet facing. Because then there is a path from the outside world to your service. So here again, if it's internet facing, it's probably more priority than if it's not. Then you want to understand basically what type of data your service is dealing with. If it's sensitive, then it's probably more a priority than if it's just like, I don't know, like a log service or a service or a service that is not that important. So here again, that's a way you can prioritize things that are related to sensitive services, like critical services in your environment. And finally, well, basically, you want to know if the finding is actually loaded in memory. So what I mean by that is that you have like a list of packages that are installed, but not everything is really loaded in memory. For example, you can add packages in your package.json or requirement.txt that at the end are not used in your code. And so what's not really used in your code, basically, it's not really exploitable because the exploit, the finding can really is not loaded into memory, and so there's no way you can really exploit it. So here again, if it's not loaded in memory, then you can deprioritize it because basically there's no real risk until it's really loaded. And if it's loaded in memory, then probably it's exploited and you should prioritize it. So that's really like, it looks like a simple triage process, but it's actually something that is very challenging and time consuming because not every company has all this information ready at hand. It's a lot about the context, and that's at scale is really challenging to collect and have it up to date. After the triage, you have a third phase, which is the validation. Yarin, can you go over that and explain to us a little bit more about the validation path?
Yeah, of course. So I think that this is the exact area where the integration between Jit and Upwind comes in place. And to first understand how we're able to, I guess, if it's a production workload, if the package is actually being used, if the vulnerable function is executed, and if there's any sensitive data, let's jump for a second to the Upwind platform. And from that moment, we'll be able to show you exactly how you get this information and findings. So in the Upwind platform, we have the vulnerability side of the house. So effectively, when you integrate with Upwind, we deploy an eBPF sensor. And this eBPF sensor is responsible for scanning all the vulnerabilities in real time. And from that, let you know what are the packages that are vulnerable, that are actually getting traffic in real time. And not only that are getting the traffic, they are being loaded to the memory and being executed. And why it's important for you? Because if you think about scenarios such as Log4j, if Log4j is just installed on your machine, and you guys know developers writing their code, sometimes they ended up not using the packages that I have in the manifest file, in the build Maven, the build Gradle, the package.json, the pip file logs files. In reality, they just have it installed and the software is not using it at all. And even if the software is using this vulnerable package, it doesn't mean that they have any exposure. It doesn't mean that they are actively to get a traffic from some malicious actor that could potentially compromise and exploit this vulnerability. So with the Upwind intelligence that is being streamlined to the Jit platform, that's exactly what we will do of this correlation. And we do this correlation because we have this eBPF sensor that we deploy with the customer's environment. And the eBPF sensor, think about it, is not just an agent that looks for processes, malicious processes, and network. It's also looking for every package execution and every package occurrence and every function that is vulnerable that is potentially being in use in any cloud environment. So I'll hand it over back to you now that we understand how the technology actually works and how the data flow comes inside. And I'll hand it over back to you, David.
Yeah, thank you, Rain. So we just talked about the validation and how we can verify that something is really an issue and something that you really need to fix. The last step is basically remediation. Now, remediation is also challenging because there's actually three different type of tasks that you need to do in order to complete remediation. First of all, you need to understand when you have a certain version of a package, what should be the version that you need to upgrade the package to in order to remediate to the finding, in order for the vulnerability to have been fixed, or the CVE to have been fixed. The second is that, and usually it also happens before, that you also need to, as a security specialist, you need to understand who is responsible in your development team for the specific finding or the specific service, so that you can delegate and assign basically the work to this person that will go and review the PR where you can upgrade the package. And finally, and that's basically the longest part in this process, that you need to understand and make sure that if you're now upgrading this specific package, you're not breaking your application. Because at the end, there is always a balance between security and make sure you're not disrupting production. So that's usually something that is a real challenge for developers, because even though they have unit tests, integration tests, end-to-end tests, it's never 100%. And so ensuring that upgrading some package doesn't break any functionality in your application is always something that takes a long time. And that's usually also where the dev team is kind of pushing back on the security team, because it's basically a matter of their focusing on deploying to production new feature, and that actually slows them down. So it slows every new version out every time there's a new vulnerability that need to fix and packages to upgrade. So ideally, if you want to please your developers, you need to understand which packages are the ones that uniquely pose a risk, so that you can prioritize which one you want to focus on, and not having to spend too much time and waste too much time trying to investigate packages that at the end don't need really to upgrade. So how can do that? Basically, this is what I just showed, is at the end, SCA is being a blocker for software agility, because both in the PR, when you have like this SCA scanner that is running in your PR, which is called the scanner scan gate, basically every time an SCA scanner finds an issue with the package, you can you need actually to deal with that and change the version of the package, and then probably also review everything you've worked on in this PR when you introduce your new package in order to pass the test. But the biggest issue is with post-deployment SCA. Basically, since any day there can be a new CVE on existing package, you need to run your SCA scanner every day. Now, once something is out on production, if you run a scanner and you find out a new issue, try to think about the overhead of a developer team that now needs to go to maybe some service they haven't touched for a while, and they need to upgrade one of the packages, one of the dependencies, to remove the vulnerabilities in production. That's a huge headache. And so at the end, SCA at the moment is really blocking the agility of the team, and there should be a better way to deal with that. So this is what we want to propose to you right now, is to present you the path forward with automation and context in mind. Basically, we joined forces, Upwind and Jit, and we're proposing a solution that streamlines the way you can manage your supply chain risk by, first of all, ensuring with Upwind that you only deal with the packages that are loaded in memory using eBPF. So Upwind can detect any issue that happens at the runtime using their sensor. So really loaded in memory and external accessible and having some serious CVE. And then they streamline stream their the data into the knowledge graph of JIT that has additional information, like, for example, business criticality of application, and other type of findings that you can correlate, so that at the end, you can leverage the JIT agents to open automatically a fixed PR only on the packages that require fixing. Okay, Yarin, do you want to add something else to explain exactly how we're working together?
Yeah, so I think that the very interesting concept about that is, and you also see it in David's demo after that, once you see the findings from the Jit platform. But the real hard problem that we're seeing right now with automating vulnerabilities and issues and all the detection, triage, and validation with AI agents is that they still doesn't have the real-time context in some cases. And while yes, well, if you have an AI agent to prioritize and do all the detection, triage, and validation and remediation, you will get a lot of value. And that's exactly what JIT is doing and becoming now the industry leader in these areas. And getting more context from real time just puts JIT in a whole different position. And this integration between Upwind and JIT just allows Upwind to first get a lot of visibility about the remediation and the triage that JIT is providing their customers. And from the Upwind side, Upwind is able to provide JIT all the context that is just missing for all the AI agents out there. And that's why I think that this integration and partnership is really valuable. And yeah, we'll see that in the demo.
Yeah, let's jump into the demo. So what I will show you now is basically the unified backlog that JIT provides to all our customers that really includes all the different scanners that JIT supports from code to cloud. So here you can see like a lot of different scanners here in this environment, from CSPM, secret detection, SAST, SCA, all these different scanners that are here. Now, what I want to show you is actually focus on a specific finding here. This is a finding about a repo called Juice Shop. For all the AppSec engineers in the audience, probably like a very well project that you all know. So in this specific project, there are some vulnerabilities, of course, because it's a project that is vulnerable by design. So what you'll see here is that if I'm clicking on this vulnerability, basically JIT will provide you with all the context. Let me actually put it a little bit bigger so you can understand what's the context here. So it started with this GitHub repo that has a bunch of CI/CD workflows that we automatically discover while we pause for the code here. Now we found one finding that is highly severe, and we have a fix available specifically here. That's using our scanner for the SCA. Now, if you're looking, this finding is attached to a package called socket.io with a specific version. This package has a bunch of dependencies, but what we couldn't say here in JIT is like how much this package is actually used in production in real time in runtime. So this is where the Upwind integration comes into play. As you can see here, Upwind managed to find issues on multiple of those packages, both on the root package, no, actually not on the root, but yeah, both on the root package and on sub package, on dependencies of these different packages. So here what you can see is basically there is a vulnerability here on this sub package. There's a vulnerability here on the engine.io, which is a dependency of this root package. There is also a dependency here, a vulnerability here. So you can see basically all these different issues that Upwind found. And Jit actually makes everything super clear because we can really draw the whole dependency graph of all the packages and provide you with all the different contexts here. And that provides you for certain that the information that this package has some vulnerabilities and you need to actually upgrade to a newer version to remove all these vulnerabilities. Now, what we can also do here, if you click here on one of the link, you can actually go into the Upwind console and see a detail of this specific CVE. So here you can see again, like the whole flow. You have also a graph here. You can see the engine IO package. You can see that this application has been discovered to be internet accessible, and you have like a lot of different information, complementary information on the finding itself. Something else you want to highlight here on the console, Yarin?
I would say that also one of the things that we'll be adding very soon to the Upwind platform is also some more context from the JIT side of the house about how these findings like to have more of a bidirectional visibility. So this is like the first phase, which provides tons of value to JIT customers, but soon Upwind customers that are using JIT will also be able to see the findings inside the Upwind platform. So there is a lot of more to expect in these areas, but yeah, this is definitely how Jit and Upwind was able to address a very challenging issue right now, where still you can prioritize the vulnerabilities and do the triage and assessment very well. But at the end of the day, if you have a real-time context to support that, it will just be for sure much more accurate and less noisy than any potential solution. So really appreciate the Jit team for this partnership.
Likewise, it's really a great collaboration and really benefits all our customers. So just to give you a few takeaways before taking any question, basically what we have shown here is that modern supply chain security risks are accelerated by AI. Once the CVE is disclosed, basically attackers use AI to rapidly build and test exploits, compressing the exploit window. And so the scale and the speed at which attackers can operate today makes really traditional remediation timelines insufficient. And so SCA has been one of the processes that people have been implementing for a while to deal with this supply chain security. But the problem is that, as I said, it's not enough in the AI world. So what we're suggesting here is basically a solution that combines automation and context, and that will give you scalable security. So, Yarin, any closing thoughts you want to share?
Yeah, I think that everything was pretty much said. We're all very excited for this partnership with Upwind and Jit right now, and I would say that from our standpoint, having an integration like one of the first integration that we have done also in the AI agents and the agentic AIs when it comes to triage and automation. So this is one of the most exciting moments because we've never been integrated with companies that are doing these things, and this is a very good milestone for Upwind customers and also for Jit customers. So thanks everyone for joining. And if you have any follow-up questions, feel free to hit David or me, and appreciate the time.
Thank you very much, everyone. Have a good day.
All right.